Good afternoon, and welcome to my presentation for operating systems. For my presentation, I did RISC V in operating systems, presented by me, Evan Colwell. What is RISC V, you may ask? Well, while doing my research, I was asking the same question, and I found out very quickly that RISC V is actually an instruction set and architecture for processors. But along with doing my research for what RISC V was, I found out that it's very beneficial to operating systems and also the future of computers in general. So RISC V, like I said, is a reduced instruction set computing for processors. Strictly an instruction set for processors, and it is simple instructions. It has simple instructions meant to run in the shortest amount of time possible, meant for speed. And this is designed for, at first anyway, low-powered applications and just theoreticals at first. But this is supported by many big names in tech. The history of RISC V. RISC V was invented, well, sorry, I'm getting ahead of myself. RISC itself, the reduced instruction set computing architecture, has been around since the 70s and 80s, researched by the University of California and also the University of Stanford. But RISC V is an evolution of that uses the reduced instruction set. And RISC V is actually created chips based off of their research. A pretty similar way to think about this is it's similar to ARM. But RISC V itself was invented in the 2010s, specifically May 28th of 2010, supported by big names in tech such as NVIDIA, Google, IBM, and Huawei. Why RISC V? RISC V is an open source architecture. Because of that fact, it can be used by anyone for free, which means anyone can develop an operating system, anyone can develop a kernel, anyone can write for it without having to pay a company to use their instruction set. RISC V is efficient, power efficient, and also efficient in its speed and how much time it takes to run its instruction set. Like I said, it's similar to think about it like ARM. And now we've seen how ARM works in like things such as like the new MacBooks and stuff like that, making it a lot more efficient and power efficient to the point of making computing in general just easy to use and less draining on power. And RISC V is, like I said before, has been supported by many big tech companies. So it's not going away anytime soon, and it's growing in support, not losing support. And more importantly with RISC V is there's no legacy hardware, no legacy backend, nothing to keep with it like x86 architectures do. So that means that if you wanted to write Windows for RISC V, you wouldn't need to maintain the support for old versions of Windows that run on older RISC V chips or older machines. So there's not that like necessary bloat, which will make any operating system written for RISC V a lot faster, a lot smaller in size, and a lot quicker to load. And going from there, RISC V isn't centralized. No one company can control what RISC V creates and what RISC V chooses to do with their architecture. So Um, it's more of the freedom to do and to build on RISC V than any other architecture. Going from there, RISC V with operating systems. Due to the early nature of RISC V, there aren't that many systems out in the wild for RISC V. In my research, most systems that I found were microcontrollers or FPGAs, stuff that would run machinery or stuff that you would see in a factory or in like a smart car or something not suited for like personal computing. However, RISC V provides the tools that you need to build an operating system, test CPU designs, and to create software with RISC V. And from there, you can produce a chip on your own. You can create a computer. You can create an operating system using RISC V. And at this moment in time, the only operating systems that I were able to find that support RISC were FreeBSD and most Linux kernels. Due to the help of Western Digital, RISC V has the ability to use Debian and most other Linux kernels, along with the recent support of the programming language Rust, which is used for security. It's a more secure-based C and C++ style language. And one of the other things that RISC V is good at, since it's really quick and really fast and efficient due to the instruction set, is it could run real-time operating systems that would be used for something, say, like a car or a rover on a different planet, or something that needed to operate as quick as possible and to come up with decisions as quickly as possible. Moving on, most other architectures compared to RISC V are not open source. Both ARM and x86 aren't open source. ARM is controlled by ARM Computing, which they basically just make CPU designs and they let other companies build them for them. And x86 processors are controlled mostly by Intel and AMD, with some other smaller companies making chips as well. There's no need to support legacy code like I mentioned before, which improves its speed and size. More efficient and faster than x86, which means it's similar in power and similar in efficiency to how ARM chips operate, but it's open source and you could design your own without having to pay ARM. It's reliable due to that open source, because since it's open source, everyone can see the code. So people around the world can read the code, make suggestions, make improvements, and sound the alarm bells whenever they notice a security flaw, which means security from the onset, where you won't have the vulnerabilities that x86, specifically like Intel chips, have, like the Spectre and Meltdown vulnerabilities that affected Intel CPUs. And this would be really effective for use in infrastructure and servers, is another one of the main goals that ARM is trying to capitalize on here. Because since they're trying to go for Linux support and running securely, it would be more reliable for and more cost effective for big companies that have infrastructure to be running RISC V to keep their system secure, and along with that, keeping their operating system secure as well. The downside to RISC, however, since RISC V is pretty new onto the scene when it comes to CPU designs and instruction sets, it has limited support. It has limited operating system support. Most of the talk over RISC V is purely technical and theoretical. There's only a few demonstrations, and most of them are small. However, the biggest producer of RISC V computer chips at the moment, Sci5, has announced that they are going to be making the first personal computer with RISC V in early 2021. The first operating systems purely meant for RISC V are far off at this point, but there's support for things such as the Linux kernel, Debian, and other things through the help of Western Digital, which will draw in more audiences and also the use of infrastructure as well. And they're really breaking the mold, breaking the norm, and doing something that other companies haven't really done before. Like, an open source processor is just something that people haven't done before, and it's taken them 10 years to come up with the first computer for RISC V because they had to do their research, they had to do their engineering, and they had to create something new. Beating proprietary old architectures and old operating systems, such as the ones from Intel, ARM, and AMD. And because of that, they are just now seeing the benefits of that. And until they start having widespread use, it's going to be a slow and steady increase for RISC V. But the future for RISC V looks bright. RISC V has eventual PCs on the horizon, with using the RISC V architecture. Along with that, they've got the future operating systems and future support for compilers and other tools. Like I mentioned before, Rust, the Rust compiler already works for RISC V, and because of that, you could start building an operating system using Rust, which will make operating systems built on RISC V even more secure due to both RISC V's security benefits along with the security benefits from using Rust itself, with it being a more secure version of C and C++. The future of RISC V is also used in FPGAs, which will be used in factories, microcontrollers, and things that you don't need a general purpose computer for. So specific applications like automated cars, or machines, or drones, or even rovers on other planets. And in the future, expanded support is coming, and implementation by many companies, because there are over 100, and from writing this presentation, there's over 200 members of the RISC V organization that pledged money and support of RISC V. Anywhere from big names such as NVIDIA, Google, Qualcomm, Huawei, WD, IBM, to more smaller companies such as the Raspberry Pi Foundation, Arduino, and just companies like Intel and Microsoft. And it adds competition overall to the processor space, which is good for everyone, because that means Intel and AMD and ARM are going to have to work harder to make their processors more secure, which means your operating systems will be more secure, which means your operating systems will run faster, which means your operating systems will try to run more efficient, because RISC V is putting that threat towards those other three big names. And that, I believe, is probably the biggest thing that RISC V can do at this moment in time, is to put the pressure on other companies to do better, such as AMD, Intel, and ARM, to make their systems better and make their systems more secure. And that completes my lecture. Thank you for joining me, and I have my sources listed here. I have 4 slides of sources. So, anyway, thank you, and have a good day.